Welcome to this online consultation event for the Barrhaven Light Rail Transit and Rail Grade Separations Environmental Assessment Study. This video provides an overview of how and why the preferred alternative for the baseline station to Nepean Sportsplex portion of the study corridor was chosen. Let's begin. Planning and design issues that needed to be considered when developing and evaluating design alternatives included reviewing the 1997 EA plan in light of the change to LRT, along with new information on background geotechnical conditions, addressing all modes of transportation during and after construction, community and underground infrastructure impacts, and capital and operating costs. This analysis led to three key design considerations: grade separation, geotechnical conditions of concern, and the limited right-of-way through a pinch point between Knoxdale and West Hunt Club roads. As an extension of the city's O-Train, this project must use the same design standards as the rest of the network. This means the LRT system needs to be grade separated at all transportation corridors. Early in the study, it was determined that the close spacing between the streets and the CN rail line crossing the corridor, combined with the design grade for the LRT, doesn't allow combining underpasses and overpasses along the line. Therefore, the preferred alternative, either below grade or elevated, must be used for the entire 2.4 kilometer length from baseline station to the Nepean Sportsplex. We know from other city projects that beneath a thin layer of topsoil and fill are layers of sensitive marine clay and permeable materials including sand, silts, and glacial till of varying thicknesses that extend down to the underlying bedrock up to 25 meters below the ground surface. This existing water table is very high throughout the study area, in some places extending up into the clay layer. Construction of any below-grade LRT facility would extend into the permeable sands lying beneath the sensitive marine clay layer. The bottom would be several meters below the existing groundwater, so the facility needs to be designed to prevent any lowering of the surrounding groundwater level outside of the trench. If not, this could result in the settlement of homes or buildings up to 250 meters either side of the LRT alignment. A GIS-based analysis demonstrates that over 640 homes and over 40 commercial, institutional, or business buildings could be impacted. A focused evaluation through the pinch point would determine the preferred alternative for the baseline station to Nepean Sportsplex section. Two alternatives were screened out early in the study. The first was locating the LRT in a bored tunnel. Both shallow and deep tunnels were considered and screened out due to geotechnical and cost considerations. The second was to locate the LRT on the east side of Woodruff Avenue. It was screened out as not being compatible with the corridor to the north and south, limits space for active transportation, conflicts with existing utility infrastructure, and significantly disrupts transit and traffic operations during construction. On this basis, 6 alternatives were identified: 4 within the Woodruff Avenue right-of-way, and 2 to the west of the right-of-way. Alternatives 1 and 2 are below grade within the Woodruff Avenue right-of-way. Alternative 1 is a cut-and-cover tunnel running under the southbound lanes of Woodruff Avenue. Being fully buried, all of the right-of-way is available to renew Woodruff Avenue as a complete street. Alternative 2 is in an open trench on the west side of the Woodruff Avenue. The space needed for the trench permanently reduces roadway capacity and is insufficient to renew Woodruff Avenue as a complete street. Both alternatives are expensive and complex to build and introduce geotechnical condition-related risks. The space required for their construction, which will likely take 3 years, will significantly disrupt roadway capacity for all modes, leaving no space for separate cycling facilities. Alternatives 3 and 4 are elevated within the Woodruff Avenue right-of-way. Both provide the opportunity to shift the alignment south of West Hunt Club so the station is on the same side as the Nepean Sportsplex. Alternative 3 locates the elevated alignment within the median of Woodruff Avenue, while Alternative 4 locates it on the west side of the Woodruff Avenue right-of-way. Both alternatives are less expensive and complicated to build and don't entail the geotechnical risks that below-grade alternatives do. Less space is required for their construction, which will likely take 2 years. Reduction in roadway capacity for all modes is less than for alternatives 1 and 2. Separate cycling facilities can be accommodated for the full duration of construction and utility relocations are avoided. Alternatives 5 and 6 maintain a continuous, straight-track geometry throughout the entire corridor, consistent with the approved plan to the north and south. Situated west of the Woodruff Avenue right-of-way, They directly impact some existing residential properties. Alternative 5 is a below-grade trench, while Alternative 6 is an elevated guideway. Both alternatives require property and displace existing residences. However, they virtually eliminate all disruption to mobility during their construction. The existing sidewalks, bicycle lanes, bus-only transit lanes, and travel lanes on Woodruff Avenue are maintained. The alternative evaluation process considered a broad list of criteria responding to all aspects of the environmental sustainability, including transportation system, NCC Greenbelt, ecological and physical, land use, and community and economic. A total of 14 categories and 37 indicators were used. In general, the below-grade alternatives expose the city to more risk and liability associated with the geotechnical conditions and are more expensive and take longer to construct. While they have less noise and visual impact, they may be perceived as a barrier that reduces connectivity between the community and Woodruff Avenue. The elevated alternatives are cost-effective with straight-track geometry, but may introduce concerns about noise and privacy. They avoid the risks associated with the geotechnical conditions and impacts to underground services and utilities. They also have potential for using the space below them for mobility or other uses. This chart summarizes the evaluation results. Alternative 6. Elevated west of Woodruff was selected as the preferred alternative. Let's examine why. Any lowering of the surrounding groundwater table by building a below-grade facility would impact the clay layer above and potentially result in settlement of surrounding structures and underground facilities. To prevent permanently lowering the groundwater, watertight construction methods are required, which are both complex and expensive. Maintaining the integrity of a continuous 2.4-kilometer-long watertight structure over the life of the facility would be a significant challenge. Any leaks would be very difficult and costly to repair. Even small leaks in the permanent structure can result in groundwater lowering that may take place over many years, resulting in damage claims years after construction. To understand why it's both complex and expensive, let's see how you build a below-grade trench LRT. Interlocking piles will be used to create a parallel set of watertight walls along the entire 2.4-kilometer length of the trench. A steel liner is driven through the ground until it is at least 3 meters into the bedrock. Then reinforced concrete is poured into the liner before it is removed. This operation is completed for the entire length of one wall and then the other, followed by excavating the area in between the walls. A permanent concrete base slab is then anchored to both walls, forming a watertight unit to support the LRT rail tracks. Precast panels will cover the tunnel walls, and the LRT tracks will then be installed. Construction would likely take a minimum of 3 years. In contrast, building an elevated guideway is more straightforward. The guideway will be supported on structural piers spaced every 30 to 40 meters along the 2.4-kilometer corridor. The pier foundations are built by driving a single steel liner until it reaches bedrock. A socket is drilled into bedrock, then a reinforcing steel cage is lowered into the hole and filled with concrete. The reinforced concrete pier is extended above ground and topped with a pier cap. Precast concrete girders that span between the piers are then erected using cranes. A reinforced concrete deck is installed on the girders to support the LRT rail tracks. It would likely take 2 years to construct this alternative. The continuous watertight walls of a below-grade trench effectively cut off several utilities that cross the LRT corridor, including large storm and sanitary sewers. Each will require a unique solution. Some of the smaller ones may be punched through the trench walls passing through a watertight sleeve. However, some will require significant and costly relocations to connect elsewhere. The elevated alternative avoids conflicts with the underground utilities and thus does not require complicated solutions to maintain existing or provide new crossings. To summarize, the elevated alternative avoids geotechnical risks and all underground utilities crossing the corridor. It is simpler, faster, and less expensive to build. Completely covering a below-grade trench to avoid creating a community barrier is not a viable option, and it has additional costs such as the need for ventilation systems and emergency exits. Any potential visual and noise impacts can be mitigated using best practices. The elevated alternative provides opportunities to animate, program, or landscape the space underneath, including a new multi-use pathway. West of Woodruff Avenue is the shortest and straightest alignment that avoids impacts to Woodruff Avenue both during and after construction. It eliminates curves that increase wheel noise and passenger discomfort that also result in higher vehicle and track maintenance costs. It reduces impacts on traffic, improves sightlines at intersections, and provides the opportunity to build a continuous, multi-use pathway the full length of the corridor. This option will impact 120 of the existing 205 residential units between Knoxdale and West Hunt Club on 3 property parcels. The portions of these properties not impacted by LRT could be redeveloped to replace the units displaced by LRT construction. 3 new elevated stations will be built. The station platforms will be accessed by stairs, escalators, and/or elevators from ground level. A plaza at the station entrance will provide seating, landscaping, public art, and bicycle parking. Tallwood Station will be built in the southwest quadrant of the Woodruff-Tallwood-Meadowlands intersection, adjacent to the City of Ottawa Archives building, providing access to the surrounding communities. A parallel multi-use pathway along the west side of Woodruff Avenue provides pedestrian and cycling connections to the station. Knoxdale Station will be built at the northwest corner of the Woodruff-Knoxdale-Medhurst intersection. This station will provide access to surrounding communities such as Tanglewood and Manordale. Nepean Sportsplex Station will be built on the west side of Woodruff Avenue across from the Nepean Sportsplex facility. A pedestrian bridge will be built over Woodruff Avenue, providing access to and from the east side. The new parallel multi-use pathway on the west side of Woodruff Avenue will cross to the east side to connect with the existing pathway that extends south to Barrhaven. A preliminary impact assessment was completed to identify where additional mitigation may be required and to make recommendations for the EA report. Some of the findings and recommendations include: a noise and vibration study indicated that no mitigation is required along the elevated guideway. Redevelopment concepts can protect privacy by optimizing design and orienting residences appropriately. Lessons learned from the current Confederation line will be employed to manage snow on the elevated facility. A corridor landscaping and space programming opportunity strategy will be developed. Further information can be found in the additional videos, presentation boards, and role plan drawings accessible on this website. For more information and to provide feedback by Wednesday, September 23, 2020, please visit www.ottawa.ca/barhavenlrt.